Welcome to my presentation. Today we will be talking about tuning Java driver for Apache Cassandra. My name is Nenad Bozic. I am coming from SmartCat company based in Novi Sad. We are doing data engineering, data science, and DevOps to provide end-to-end data science solutions. Why this talk? Basically, we are working with many technical teams out there. And based on our experience, we realized that people are starting with Apache Cassandra real easy. Just install everything, add the driver to your application, and you can start writing and reading from it. You can look like this guy, mostly lying on the beach, occasionally looking at monitoring, and everything will work just fine. Then you will get familiar with technology, read stuff on internet, and you will try to use it as a single database for any kind of load, and Cassandra is not a silver bullet. This is how things look like when people call us for help. This is good for us because it is additional work for us, but I wanted with this presentation to give you a couple of hints based on our experience and what you can do better when you're configuring stuff on driver level to avoid some pitfalls and not to end up like this. So this is agenda. First we will run through intro to Apache Cassandra. How many of you are using Apache Cassandra? Okay, and how many of you do have Cassandra cluster in production? Cool. So we will run through brief Apache Cassandra intro, then we will proceed to touch tuning options of on driver level. Why on driver level alone? Because Cassandra is client-server database. My colleague from SmartCat, Matija Gobec, gave a good talk on DataStack Summit last year, how to tune server-side Cassandra, and I didn't found many good resources how to tune driver level side, so I wanted to give a talk and you can have a whole picture. And we will finish off by some use cases where I will use all the things that I talked about in tuning options to walk through use cases, how we can configure this driver, and we will finish up by takeaways and Q&A. So let's start off with Apache Cassandra. Apache Cassandra is a distributed database. On previous talk, there was a good intro about CAP theorem. CAP theorem is something that you will look firstly when you are using Apache Cassandra, because it's a trade-off between resilience and consistency, and you cannot have both. Replication factor is important. It is the rule on how many nodes you have data in the system. It is masterless in a sense that on each request you will get a different coordinator, and this different coordinator will respond with data, and each node in the cluster can be coordinator, and it has seeds, and you can bootstrap whole cluster through seeds. And what is nice is native multi-data center support. We will see this later on, but out of the box you can deploy a Cassandra cluster into 2 data centers, and you can have resilience in case one falls down. You have still the other alive, and both driver and cluster knows how to handle that. From client, as I said, you can have each node be the coordinator for your request, and when you are issuing a request, by load balancing policy you will get a certain node and wait for response to be back on your client. And this is, in our case, in this example, I wanted to give one example with three nodes as replicas. So basically we're issuing requests from client side to coordinator internally queries all 3 replicas, and you have tunable consistency options. In this example, I used the consistency level 1, which means that only one replica should respond, and this will be fastest responding replica. Consistency level, we say that Cassandra is a database with tunable consistencies, so you can choose either to be fully consistent by providing consistency level 3 and then wait for all 3 replicas, but then you are not resilient. One failed node would mean that you won't get data back. In this example, I use consistency level 1, so you would choose that if performance is more important than full consistency. And this fast responding replica will return data to coordinator, and coordinator will send response to your driver. I mentioned that it has multi-data center support. Both driver and cluster can connect to multiple data centers, and this is convenient. You can think of European data center and US data center, and you want to serve data from data center which is closer to your customers. So both driver and cluster knows how to serve data from local data centers. This opens up cool possibilities. When one data center is down, you can reroute your traffic to the other data centers. You can mix loads. You can have analytics load and real-time load in same database. Basically, you put one data center to be your real-time database and the other data center to serve for analytics purposes, and the data will get replicated automatically. You don't need two databases for this. In Cassandra, we say that we are doing query-based modeling. Upfront, we need to know how we will read data in order to create table definitions. In both of these cases, data can be queried by primary key. In upper right part, we want to query account by email, and email is our primary key. And in second example, we want to have account by external source, such as social media account. So we need the composite key of social media type and ID on social media. This will result in denormalized data and a lot of duplications, but this is how performance is achieved. Cassandra, as we will see on this slide, is not good for prototyping. You cannot have dynamic queries and you cannot have referential integrity out of the box. But Cassandra shines when you need time series data, click analytics, event sourcing. You can think of many of us are using Google Analytics on a daily basis. So perfect load for Cassandra is clickstream where user ID would be key, and then you have time series of click events happening on web browser. You should avoid Cassandra in early prototyping phases. Better choice, in my opinion, is MongoDB or some kind of relational database, because each transition to new way of querying data would result in remodeling your data, and this will slow you down. Better thing is to just use some prototyping database and move to Cassandra when you are certain that Cassandra fits your use case. It is bad for referential integrity. Use relational databases for that, and it is bad for dynamic access patterns. In Cassandra world, DataStax, which is enterprise version of Cassandra, solve that by putting Solr on top. So solution would be to put some kind of in-memory indexing engine on top. So let's talk about tuning options. There are different drivers, first of all, and we are speaking here about Java driver because Java driver is most mature one. People in the field a lot of times are choosing Java driver. Cassandra is database written in Java, and it makes sense to use Java driver, and it has most of features. But you can find things that I'm talking about in different drivers as well. Your application is connected to a cluster through session. You define session, and each session has load balancing policy. Load balancing policy is responsible for choosing coordinator, and we have different options here. Connection between our application and cluster is maintained through pool of connections, and pretty much load balancing is responsible to put load evenly on each node. By default, you get data center aware load balancing policy, which is cool because you will get always a response from local node, their local data center. There are ways to configure what is local and what is remote for your application. Also, by default, you will get token-aware policy. Primary key can be hashed on driver level, and each node is responsible for token range. So with token-aware policy, you will land on node holding the replica. These load balancing policies are chainable, so you're not limited to only one of load balancing policies. I mentioned that default, when you don't configure anything, is DC-aware plus token-aware, which will mean that data will get served from local data center from node which holds data. There are many different options when we are speaking about load balancing policies. There are filtering policies. You can white label certain nodes for certain primary keys. And one which is worth mentioning, we had really good results with latency-aware policy. This is a load balancing policy not used a lot, but it is really good when you have infrastructure, for example, deployed on AWS or some cloud provider. There are a lot of hiccups, CPU steals, network hiccups, and latency-aware policy mitigates this. It keeps track of latencies to each node, and it is penalizing slow-performing node while choosing fast-performing nodes. People do not use it a lot because there are a couple of parameters which you need to configure in order to work good, such as I listed here a couple of them. Exclusion threshold, this parameter tells the driver how bad should not be in order to penalize it. 1.2 means that nodes 20% worse than fast-performing node will get penalized. Default is 2, so this is like more aggressive penalization. Scale in milliseconds, how much of significance you want to add to historical points. If this is lower, then you want to put more significance to recent measurements than older ones. Retry period, for how long it should penalize the node. Update rate in milliseconds, it is not calculating this average of latency for each request, but in this time window. And minimum measurements. We should not penalize from start. We need the amount of measurements in order to start measuring. The other important thing which you can tune, I said that driver is maintaining a connection to each node by pool of connections. So there are a couple of things that you can tune there. Datastax made a significant change when going from version 2 protocol to version 3 protocol. And this is not highlighted enough, so I wanted to emphasize it here. Previously in version 2, they had core connections and maximum connections, and default was 2 and 8. So pool of connections either shrinked or expanded based on your workload. Then they realized that this is expensive operation, so they removed that. And in version 3, we have core and maximum put on 1. So you have single connection, but what they did, they increased the maximum number of requests going across single connection from 128 to 32,000. So this is significant difference. And if you want to tune, for example, parallel request per connection, my advice is first to add monitoring. And this is not out of the box added to driver. You can get state from session, and out of that you can monitor in-flight queries, and you can figure out in each moment how many requests are going through this single connection. When they went from version 2 to version 3, we had 8 connections and 128 requests per connection, which adds up to 1,024 requests per connection. They left 124 as default requests per connection for version 3, which is really low. If you think of limit, which is 32,000, this is 32 times more. I emphasized here that this number, and you can increase it. But as I said, have a good monitoring in place, both on cluster side and on driver side, especially on cluster side. Increasing this number would mean that you will put additional stress on your cluster, and you need to be sure that your cluster can handle it. Next thing which we want to cover is speculative executions. This is again something which I rarely seen production, and we had really good results with it. Speculative execution means that you will tell the driver to spawn additional queries after configurable threshold, and by that you can avoid if certain node is stuck doing some background operation. On picture on left, you can see that query to host 1 is issued, then it didn't respond. After certain configurable amount of time, query to host 2 went away, and host 2 responded before host 1. It will cancel the request to host 1, and it will return data faster than if you had to wait for host 1. The other image is the same scenario, but in this situation, host 1 responded before host 2, and it canceled request. Pay attention that after version 3, they added in driver marking of idempotency of queries. So if your query is not idempotent, speculative execution won't work. You need to make sure that your query is idempotent, and for idempotent queries, speculative executions will fire. We have speculative executions in 2 flavors. I created this presentation in Google Drive, so PowerPoint changing to PowerPoint didn't help. Upper part is constant speculative execution policy. You have 2 parameters to pass to this speculative execution policy. First is time window to wait for additional requests, and the other is number of additional requests. So you will issue a query for host 1 after 50 milliseconds, and if you don't get response, you will issue a query to host 2. And after additional 50 milliseconds to host 3, in total of three requests. The other option, the other flavor of speculative execution is percentile speculative execution policy, and it works similar like latency-aware policy. You pass it latency tracker, percentage of badness, and the number of additional queries, and this latency tracker keeps track of latencies to each node, and this badness will tell all queries above 99% in our case of badness will get additional retry and additional retry. Last the number is number of additional retries as in first example. Next thing which we want to cover are timeouts and retries. Timeouts are in my opinion obvious, but many people do not configure them properly. We have timeouts on driver side and on server side. On server side, we have different timeouts for writes, reads, range queries, and slowest timeout is 10 seconds, so they decided to put driver read timeout on 12 seconds. 12 seconds is, in my opinion, a lot. A lot of the times you have a constraint to have a response faster, and then it makes sense to lower down both driver and server side and trigger retry mechanism faster. Maybe you want to jump to node without the problem faster, not to wait 12 seconds and additionally choke the node which has compaction running or something like that. This setting can be done on query basis or on session. If you put it on session, then each query will have same setting. The other thing which you can configure is connection timeout. It is by default on 5 seconds, but if you want to raise an exception and retry to reconnect, you can lower that down. And last thing, important thing for resilience is retry. Cassandra has retry policies, and in our opinion, you should fail early and retry. It's much better than to have slow timeouts and pile up requests in queues because one slow request will slow down many additional ones if queue is filling up. If a query again is not idempotent, retry mechanism won't fire up. So pay attention that idempotency markers should be added if you want to have retries. We spend a lot of time figuring out why we don't have retry logic in place, and it was because queries were not marked as idempotent. And I added here downgrading retry policy. You get default retry policy, which is good for most use cases. And downgrading policy is something that that on many places on the internet you will find that you shouldn't use it unless you know what you are doing. But in my opinion, if returning data is more important than if returning potentially inconsistent data is more important than having failure, downgrading policy is perfect for you. You can put a consistency level of 3, and in our previous example from the beginning of presentation, one node is down. Downgrading retry policy will get information that 2 replicas are alive, and it can retry with lower consistency level. If you can tolerate that, then this retry policy is a good option for you. Again, important thing to do is to monitor this. This one is hard to monitor because DataStax driver and cluster do not have default monitoring in place for that. We built Cassandra Diagnostics tools in SmartCat, which you can put on server side, and you can monitor how many requests with each consistency level you have. And effectively, you can monitor then whether your requests are consistency level 3 or downgraded consistency level 2 or whatever, and you can figure out the ratio and on how many times you are returning lower consistency than desired. Okay, so this pretty much can be found online as well, so I wanted to walk through a couple of use cases which are typical for Cassandra or which we touched while doing consultancy, so I can explain better how I would choose to tune the driver's side in specific use cases. First, Iot Measurements. Cassandra is, as I said, perfect database for time series, and people choose it if you want to collect measurements from many IoT devices and visualize the data. And in this case, I would argue that it is not that important to be fully consistent, but you have huge volumes of data going inside your database, and you want to have fast access. Having 10,000 measurements and then some average from 10,000 measurements, and if you miss 2 or 3 or even 5 or whatever, you will get pretty much good results. So if you have this kind of use case, I would choose as a load balancing policy default. So I would serve, because of fast access, I would serve data from local data center, and I would choose token aware to land on the node which has data. Lower consistency level in this situation makes sense. So 1, or you can use a higher consistency level and add downgrading retry policies, as I mentioned before, because most of the times you will serve consistent data, but you can downgrade to 1 in case 2 nodes are down, so you are resilient. As a last thing, if you need additional performance, you can use speculative execution to query more nodes than 1, and this way you will avoid nodes which have currently load on them and problems. So keep in mind that speculative execution can prematurely, without network hop, do additional requests to cluster. Next use case which we can cover is warehouse use case, where you have stock data in warehouse. For this use case, I would say that it is important to have strong consistency, because if you're missing a single item, when customer wants to buy it, then it's problematic. So you need to be fully consistent for this part. And you will achieve high consistency by choosing consistency level for reads and writes to be higher than replication factor. I would choose here as a must. I would choose for any use case retry and reconnect policy, but for this one it's particularly important because you don't want to have failures of certain nodes resulting in missing data. Also, I would, when you speak about pooling options, I would choose here a lower number, because you don't want to risk overloading your cluster. And we said that this is mission critical data with tolerable performance, so I would argue that having lower number of parallel requests per connection is option here, so go with lower number. Let your cluster breathe. And I would also choose here lower read timeout to trigger retry mechanism more often and more early, and let the retry mechanism handle potential, again, overloaded nodes. Last use case was really exciting. We worked for 1 year for ad serving company, and this ad serving company had write intensive but latency. We had tight SLA in latency sense. We needed to serve ads in 100 milliseconds. Everything served about 100 milliseconds was lost ad. But also we had user analytics flying to the cluster in really huge volumes because users were clicking through some websites, and we had peaks when some important thing happens, a tornado in Miami or something like that. Then people go to certain websites, and if our customer is serving ads on that websites, we needed to handle those peaks. Because we had different loads for reads and writes, we decided to separate session. So we had 2 session objects, one for reads and one for writes. This is something that I didn't found on much places on internet, but I think it's a good idea, because then you can apply different load balancing policies for your reads and for writes. Whole infrastructure was on AWS, so on reads it made sense to us because we wanted to serve data fast, to choose latency aware policy, and we had really good results with latency aware. It penalized nodes with CPU steals and network hiccups, and it went immediately to faster performing nodes. Because of SLA, which says everything about 100 milliseconds is lost data, we lower down the read timeout, so both on server side and cluster side, to something lower than 100 milliseconds to try to spawn additional requests, because we hope that we will land maybe on a node which can serve data in time. Also, we opened up parallel requests per connection. So this pooling option, which I showed earlier, 32,000 requests per connection. Our cluster could support that, so we decided to go for that value, and we saw real increase in performance. So that was pretty much it. I want to mention a couple of takeaways from this presentation. First, and I would say the most important, is that when choosing database, any kind of database, not Cassandra only, you need to know your use case, and you need to know what this database is good for and what this database is not good for. Don't use, especially NoSQL databases, as silver bullets. Especially important is that for any kind of tuning, especially, it is important to have good monitoring in place and to have baseline. If you don't have good monitoring, then tuning is just a hunch. One day it will work better, but 3 days after you won't notice it, and your cluster will get crashed. So have good monitoring in place for each tuning option. And last thing which I want to mention is that there are a lot of tuning advices on the internet, and something that worked for me does not necessarily mean that it will work for you. Create some kind of testing suite, have load testing in place, have monitoring in place, and do this cycle. Try to adjust some parameters, then issue load test, then measure. And by these circles, you will end up with perfect configuration for your infrastructure and for your version of Cassandra. This database is really sensitive to hardware choices, and if I used i3 instances with NVMe and you're using EBS, we will have totally different tuning options. I blogged about this a lot. I have 3 blogs on Smarket website. I ran through these tuning options in a couple of more details, and third link will lead you to this ad serving company use case in more details. So if you are interested, check it out. And last link, as I said, is a presentation from my colleague Mattia, who spoke about tuning options on server side and how you can achieve crazy performance under 100 milliseconds queries with cluster deployed on AWS. This presentation, I put it on Twitter, so on SlideShare, and on my last tweet you can find the link to SlideShare. So in case you are interested, you can find it there. And that was it. Thanks for listening.
Hi, thanks for the talk. I found it very interesting. You mentioned several times the thing about failing soon and timing out, and could you expand a little bit on that? Because I mean, I'm just starting to use Cassandra, but I'm curious about like pros and cons, because I guess if you fail very often and very quick and then just retry, you are setting a lot of extra weight in the extra load in the system. So how do you measure what is the time to actually time out and when you should actually wait a little bit longer?
I would say that this is connected to complexity of the system. Cassandra on server side is distributed database, and a lot of times certain nodes are doing compaction, garbage collection, stop the world, whatever, and among, let's say, cluster of 6 nodes, certain nodes are better choice than the other nodes. And if you have round-robin load balancing policy in place, you can end up on problematic node, and this node will choke up. You will create additional load for this node. If you want performance and if you have sensitive SLA, I would advise to lower down timeouts and just fail, go to retry, and retry on next available host. And this way you didn't put much stress on node already in problem, and you jumped to the other node which is maybe performing better. Of course, you need to know when this is possible. If you have consistency level 1 and replication factor 3, it makes sense because you are just waiting for fast responding replica. If you want to be fully consistent and have consistency level of 3, if you are retry on different node, you will be in the same problem because you will wait for response from this node in problem. So for some use cases it makes sense, for some use cases it doesn't, but generally I wouldn't pile up requests in queue for default 12 seconds, and because it will pile up over time. Any other questions? By the way, I will be here for 2 days, so if you want to talk Cassandra, data science, data engineering, just find me and we can talk. Thanks again for listening.